Hello friends, Ashok Patra here. We start from 101. Of the following, which is considered the most important structure, non-ferrous metal? Aluminum is used for structural purpose, the most structural purpose other than steel. Which extrusion process uses less pressure due to lower buildups of friction container and billet? It is indirect hot working. Cold working, not less pressure. Hot working is less pressure. But indirect one is lower buildup of friction container. Hot working means it is above AC3 degree, AC3 temperature. It is about 950 around temperature. Powder metallurgy is used to produce refractory metal, which is following. Which of the following? Tungsten. Splashed metals entrapped by molten metal that doesn't diffuse is called cold shut. Which of the following is classified as non-ferrous light alloy? Beryllium base. The bottom part of the flask is known as the drag. Flask means the total container for the casting. It is called flask. The top part is called drag. The bottom part is drag. So casting process, the name which given the part which is used to represent finish item. Finish item is called pattern. So first you can put the pattern inside the sand and make the mold. So then bring it out. Okay, you can cast it. Which of the following classes manufacturing process? All: casting, welding, machining, rolling, all manufacturing process. Metal is fed into casting cavity through gating system. The riser is there is some extra metal will rise up there, and it will use for shrinkage to cover liquid shrinkage, solid shrinkage, all these things. Now the casting process which produces bar is known as continuous casting. Bar plate is continuous casting. The upper half of the flask is known as cope. So upper half is cope, bottom half is drag. So small metal supports which become part of the casting during pouring are called. So to support the core, there is chaplets. Okay. The casting process which gives improved material density towards the outside of the mold is centrifugal casting. So when it is rotating, it is giving density, improved material density outsides, towards the outside. The crystal structure of a casting adjacent to mold wall will be fine equiaxed grains because the casting mold is cool, so it is fine equiaxed, cooling quickly. In modern manufacturing industries, which of the following factors are considered? Market, product life, design, manufacturing process, all of the way. What material is usually used in injection molding, thermoplastic. Cobalt is used as an alloying constituent in permanent magnets. So when you are manufacturing permanent magnets, then you can add cobalt as an alloying element. Each of the following have approximately square cross section. Bloom and billet. Their square cross section, slab is just B, you can remember, and slab is rectangular cross section. Which of the following hole making process? Blanking, when it is, you can just round shape press directly. Notching is notch making, so I will not go for that. Products used in load carrying application require more careful testing because failure can cause loss of life, failure can cause loss of use of the product, failure can be expensive, failure can cause danger to other structures, all of the above. More careful testing. Loads which are most likely to cause failure are multidirectional. The general term for local variation in material continuity is called a discontinuity. Where an unacceptable condition occurs in the material due to local variation in the material continuity, the term given specifically to this is called a defect. Which of the following could be considered a discontinuity? Crack, changed section, drill hole, everything is the discontinuity. The study and description of material property related to analytical studies and testing attempts to quantify the toughness of material is known as fracture mechanics. A discontinuity which is deemed to unacceptable standard is called a defect. Deemed to be unacceptable standards by standards really. Which of the following is not considered a mode of failure? Elastic deformation. So elastic, within the elastic, stress is proportional to strain. So it will just return to its original shape, original length, so there is no problem. Brittle fracture is most likely to occur at low temperature. In the low temperature, material become brittle and then it can crack. So that is brittle fracture. Brittle is sudden like glass. NDT is generally not carried out on cast iron because it is generally used in application where loads are principally compressive. Porosity is composed of cavities or pores that form when the weld metal solidifies. One or more steps of processing a product would cause change of shape and properties of product A and B. So when you change the shape by forging, you are increasing the tensile property and all. Changing a material shape can be accomplished in which of the following steps? Plastic. When it is in semi, you can say plastic stage, like gamma iron, austenite. Sorry, delta iron. No, gamma iron, sorry. Which of the following is an example of reshaping? Forging. Forging is reshaping. The process of solidification during casting can be likened to that of the welding process. Reshaping of a material while in plastic or semi-solid form. So both B and C, rolling, extrusion. So semi-solid stage, you can do anything. That is called plastic stage. You can do forging also. Oh, here B and C. Which of the following could be referred to as engineering material? Plastic, metal, ceramics, all of the above. Which of the following properties of a material can be used to predict the deflection or deformation of certain size beam under known loads? Young's modulus. Which of the following must be considered when choosing an engineering material for a particular application? Cost, loading, mechanical properties, inspection cost, any of the above, or all of the above. Which of the following could affect the properties of an engineering material? Composition, heat treated condition, crystal structure, all of the above. Which of the following is classed as chemical property? Corrosion resistance, because that is a chemical property. So which is act like anode, which is act like a cathode? That is, so sacrificial anode can do save cathode. So which of the following classes are a physical property? All are physical property: density, conductivity, melting point. A test designed to determine a material's castability would be classified as looking for a processing property. Castability for casting. Internal forces acting upon imaginary planes cutting the body being loaded are stresses. A stress caused by forces at an angle to the plane is known as shear stress. At an angle, shear stress. Normal tensile stress. Means along. Which of the following may be used as a cutting tool material? Diamonds, cementite carbides. A and C. If a material is loaded until its elastic limit is exceeded, what condition will occur? The material may fracture or the material may work hardened. So if fracture means it is hard brittle material or near brittle material, when it is work hardened means it is a ductile material. So first it will work hardened, go for UTS, then it will go for ductile fracture. Let me show you something within very small time. So quantitative and qualitative tests. So mechanical tests, the quantity, you understand the quantity, how much tensile test, hardness test, Charpy notch test. So you can quantify it. Quality means how much load you are applying, all this you can quantify. Quality, qualitative test, bend test, macro examination, fillet fracture, nick break test. Nick break test used for API 1104. So So these are the specimens. So where from specimens will got, that is no problem for you. Malleability, ability material to withstand deformation under static compressive loading without rupture. Ductility, toughness. Ductility is the ability of material undergo plastic deformation under static tensile loading without rupture. So malleability is it for rolling? Withstand deformation under static compressive loading without rupture. Toughness, ability of material to withstand bending or application of shear stresses by impact loading without fracture. Hardness, measurement of a material surface resistance to indentation from another material by static load. Tensile strength, measurement of maximum force required to fracture a material bar of unit cross-sectional area into tension. For transverse joint or tensile test, so these are transverse because there is, you can see it is cut from there with weld. So with weld, that is called transverse joint tensile test. Tensile test, that is all weld metal tensile specimen, that is if only from weld it has been taken, that is for testing of welding electrodes from a new company or something like that. So you'll see UTS or tensile strength. So this is a brittle material, this is elastic material or ductile material. So in the elastic region, this there. In the elastic region, it is found by 0.2%. So here also 0.2%, that is elastic limit. That is a strain hardened. Here strain hardened. Then it is gone. It has taken some load. So this is UTS. This is here UTS. After it will just break. After it will come down and it is the area of cross section will decrease. Here very small decrease in area of cross section. So objective measuring, then Charpy V-notch test, measuring impact strength in a different weld joint areas, assessing resistance toward brittle fracture. Information to be supplied on the test report: material type, notch type, specimen size, test temperature, notch location, impact strength value. So ductile to brittle transition curve. So testing temperature degrees centigrade, 0 to -10, -20. So it becomes brittle, slowly it will become brittle. So -20 is the right ductile brittle transition joint. So most materials are tested here, like steel. So impact energy, it was given on section 2. So as per that, what material and all, we are taking that. Charpy V-notch test, impact test specimen. So 10 by 10. If you see 55 length, there is a big groove, 45 degree, 0.25 mm radius, and there is a depth also. So this V-notch impact test is just a hammer, and it will be positioned at this point like this here, and then Just a strike backside the pendulum. When it strike, it will break. How it breaks? Ductile, like this. So 100% brittle or ductile, 100% ductile or in between. So you have to find out. And how much energy it takes to break in joules. Hardness testing, objective measuring hardness in different areas of welded joint, assessing resistance to brittle fracture, cold cracking, corrosion sensitivity within H2S, hydrogen sulfide environment. Say brittle, it will go for this hydrogen sulfide environment, then it will go for embrittlement. So information, material type, location identification, type of hardness test, load applied on in inter hardness values. So there is even for here, you see Charpy, same like another test is there, IJOD test. So here it is not there. So you can look in the Google, find in the Google and see. So Vickers hardness test. There is load, timing mechanism, diamond pyramid. You can just press it with some load. When you find indentation, they have to measure that thing and they find some values. Brinell hardness test. There is steel ball 30 kilonewton. Then the dia of indentation is giving how much is the hardness. A Rockwell C, they find the diagonal of this indentation. Hardness testing. So there are 3 in the parent metal, 3, 6 here, 3 in the usually hardest zone. This is edge area 3, 3, 3, 3, and weld area 3, 3. The hardest is the edge zone. This zone near to the weld parent metal. So these are the hardness test you have to take when you are going somewhere. Fatigue fracture and stress concentration area, steel type, all grain structures. For fracture toughness, it is CTOD, crack tip opening displacement. Fatigue cracks occur under cyclic stress conditions. Fracture normally occurs at a change lock section, notch, weld defects, stress concentration area. All materials are susceptible to fatigue cracking. Fatigue cracking starts at specific point referred to as initiation point. Fracture surface is smooth appearance, sometimes displaying branch marking. The final mode of failure may be brittle or ductile, combination of both. Precautions: toe grinding, profile grinding, elimination of poor profiles, elimination of partial penetration welds, weld defects, operating conditions under material endurance limits, elimination of notch defects, mechanical damage, cap, root, undercut, selection of correct material, service conditions. Fatigue fracture occurs. Crack growth is slow. Crack may grow into the areas of low stresses and stop without failure. This is something looking like this. The initiation points. Fatigue fracture surface smooth in appearance. Secondary mode of failure, fibrous appearance. Bend. These are the bend either from root side, face bend, face side, or side bend. So root bend means from the root side. Root side in the top. Face bend is the welding top side is on the top here. Or side bend is side. The weld is looking like this. From the weld side it is cut. So from the welding side bend. So how the bending they are doing. From the root side, root bend, side, face bend. This is side bend. This weld top bottom side is the root bottom side. So it will bend on the root. It will bend on the face. It will bend on side. That's all. So fillet weld fracture test. This is a saw cut. They make a saw cut and fracture it. That's all. They find out what is penetration is good or lack of penetration is there, fusion is there, slag is there, porosity is there. So there is an expected test notch cut by hacksaw. That is butt welding. They cut from both sides and then weld reinforcement may or may not be removed. And the crack can check for this lack of root penetration, fusion, inclusion, fracture line. All things they have to check. The ultimate strength of material is the same as breaking strength for brittle material. The modulus of elasticity, also known as Young's modulus. Which of the following materials exhibit better compressive strength than tensile strength? Cast iron, concrete, wood. Compressive strength. When the metal is very brittle, which test is used to replace tensile? Transverse rupture test. Fatigue failure may be initiated from area of corrosion, surface flaw, surface notch. That is already seen. Which of the following is a notch bar test? Notch bar test, Charpy notch, Izod test. So Izod impact test. Toughness can be measured by Charpy test or Izod test. Notch toughness. Usually V notch. The same like that, and there is a pendulum. Same like the Charpy notch test. The test an STM standard method of determining the impact resistance of material. A pivoting arm is raised to a specific height and then released. The arm swing down and hitting a notched sample, breaking the specimen. The energy absorbed by the sample is calculated. Same like Charpy notch test. Hardness test can be used to determine material hardness, composition, heat treated condition. Composition means that is what if hardness is more, then it will go for problem in some H2S climates, shore, shore surface and all. That's certain. They determine that whether they want to use it or not. The superficial Rockwell test is carried out on the material when only allow very small surface blemish. So naturally nowadays surface blemish is not allowed too much on the final product. So you can go for the fine things. Superficial Rockwell, very small indented, and then finding the hardness. Calculate the factor of safety if a material is working under stress 15,000 lbs per square inch and an ultimate tensile strength 60,000 lbs per square inch. Just UTS by working load. That's all. Or working stress. In which of the following pumps are temperature indicating material available? Pellets, crayon sticks, organic liquid. All things. At what angle should a bend be normally bent? Bend is 180-degree total. Which of the following is a hardness test? Rockwell. After 180-degree, they are looking if there is any crack or something. Indication 3 mm. So many things are there as per code. You have to go find out. Stresses that act along the parallel to a plane is known as shear stress. Electrons in an atom can exist in exact energy levels in exact energy cells. A material that has high hardness and good electrical and thermal conductivity is known as metallic material. What term is used to define the change of state directly from solid to gas? Sublimation. Directly from solid to gas. It is called sublimation. Which of the following is a crystal lattice that has 9 atoms, 8 at each corner and 1 centrally between them? Body centered cubic. Let me show you something. See this one. Body centered cubic. So 1, 2, 3, 4, 5, 6, 7, 8. And there is one at the center. If you got face centered cubic, so 8 at the corner, 6 on the face. So that is the difference. Which of the following materials is body-centered cubic at room temperature? Iron. Phase-centered when gamma iron, and delta iron, then body-centered. Delta iron is liquid state. So those things, those three, delta iron, alpha iron, gamma iron, all these things are called allotropy. A property of fine grain material, that is that it will have higher strength than coarse grain. Fine grain is higher strength because many grain boundaries. Coarse grain, little grain boundaries, little resistance. So fine grain have higher strength. Permanent deformation can occur which of the following ways? Twinning deformation is something called twinning. You can just find on Google. Twinning is can directly see. Twinning is a major deformation mode in FCC material with some load and all hexagonal metals, and also occurs in FCC metals. The high value of yield strength and all. Twinning may be produced. Twinning is a permanent, prominent mechanism of plastic deformation in some metallic materials. It is a shear force that can be produced atomic displacement. Twinning may be produced by mechanical deformation or as a result of annealing following plastic deformation. High strain rates, low stacking fault energy, low temperature facilitate deformation twinning. Twinning is polar unidirectional while slip usually is not. Work done to produce plastic deformation below materials recrystallization temperature is known as cold work. Above recrystallization, hot work. Solution heat treating requires each of the following: to dissolve maximum amount of equilibrium precipitant in the solid solution. Precipitation hardening is most commonly carried out on which of the following material? Aluminium. Allotropic changes occur in solid state. Which of the following is allotropic material? Iron. So different stages there. Heat treatment process that requires a material to be heated above its critical temperature for some period of time for carbon to unite in solid solution with iron in the gamma or FCC lattice is known as austenizing. Let me show you something. You see, austempering is a treatment that's applied to ferrous metal, mostly notably steel and ductile iron. The steel is produced a bainite microstructure, whereas so it is gone there. So in the austenite region only, it is holding for some time and cooling slowly. That is getting bainite. In martempering, there is something called martempering. Martempering is a method by which stresses and strains generated during the quenching of a steel component can be controlled. In martempering, steel is heated above the critical range to make it austenite, all austenite. They heated above the upper critical temperature. So then you have all martensite. Then when you then quenched to a salt, oil, or lead bath kept at a temperature 150 to 300 degrees centigrade. So when it is there, it is the martensite start period. That is the start point, 300 degrees, 300 to 315 degrees centigrade. The temperature becomes uniform throughout cross section of the workpiece and then cooled in air or oil to room temperature. The slow cooling, that is called martempering. Spheroidizing is something else. Spheroidizing in high carbon steel is a method of prolonged heating at temperature below eutectic temperature. Eutectic temperature 620, around 620 degrees centigrade, and you find like this structure. Like this structure. The round ones is ferrite. The long ones cementite. All these things. The perlite, by heating at this temperature, perlite, which is lowest energy element in the steel, gets converted to ferrite and cementite. The ferrite is really white structure and is cementite, globular cementite. This is different. This is directly austenizing. So heating to directly above the heated above critical temperature AC3. So the face centered cubic, it is gamma iron directly coming to solid solution, and body centered cubic move to face centered lattice. It is austenization. Austenite everywhere. That's all. A process used to decrease hardness, increase ductility, occasionally improve machinability of high carbon steel is called spheroidizing. A treatment that used to give minimum hardness and maximum ductility in steel as spheroidizing. So by spheroidizing, within the martensite is there, but still it has some ductility and hardness decrease most. Localized corrosion causing deep extend holes is known as pitting. Which of the following is classified as a permanent deformation? Pinning, rotational deformation, slip, all of the above. Annealing will achieve which of the following properties? increase ductility and decrease hardness. Of the following metals, which is most susceptible to corrosion by seawater? Zinc. So that's why when you apply sacrificial anode for a sheep hull, you are applying zinc. So it is sacrificial anode, and cathode sheep is corroded less. During the hardening of steel, which of the following quenching media will produce the severest quench? Brine. Severest means good, very good. That is what very good quench. Quench means to cool. Which of the most common metallic element found on the earth in large percentage? Aluminum. The product of blast furnace is known as pig iron. What is the approximate carbon content of pig iron? 3 to 4. When the carbon content of iron reduced to 2%, it is called steel. A Bessemer converter is a method of producing steel. Practically all steel is made with the use of oxygen. So oxygen lancing, when you lance with oxygen in the liquid metal, the carbon will go for carbon dioxide and carbon monoxide. So carbon will be reduced. So you get steel. And that is the lancing process. The hardenability of steel can be tested by Rockwell test. Seizen cracking in the form of intergranular corrosion that occurs in which of the following metals? Brass. Is brass brass propellers are used in ship, so those can go for this intergranular corrosion cracking, Seizen cracking. Which of the main alloying element of austenite stainless steel? Chromium. Chromium and nickel is the main alloying element. Stainless steel is for chromium. Galvanizing is process of applying to iron and steel products a protective layer of zinc and zinc compounds. One specific type of gas entrapment is elongated with appearance of a tail. This occurs when gas attempt to escape from metal still in a liquid state. It is called wormhole porosity. Which of the following statement is true with regard to a galvanic cell? The more negative cathode metals are protected. The carbon content of low carbon steel is, so there is 0.6 to 25 point of carbon, 6 point is 0.06%, 0.25% of carbon. So either A or C. Carbon content of high carbon steel is 50 to 160 points. That is 0.5 to 1.6% carbon. The carbon content of high carbon steel is this. Okay, which of the following is not form of hardness test? Germany, Brunel, Rockwell, Vickers, all are hardness test. Not Germany. An alloy steel is steel containing one or more elements. What do the letter AISI, American Iron and Steel Institute? Which of the following is a classification of stainless steel? Austenite, ferrite, martensite, all. Austenite stainless steel most typically contain 18% chromium and 8% nickel. Which of the following metal can be magnetized? When magnetized, martensite stainless steel, ferritic stainless steel, they can be magnetized. Austenite is non-magnet. A and B. Which of the following may be used as an alloying element of steel? Copper, nickel, aluminum, zinc, all of the above. Thank you, gentlemen. We'll stop here.